Hey, welcome to the Code with Jason meetup. Today we're going to do something that I've been working on for the last couple meetups, but I think you guys might be all new to this particular project, and so I'll describe it a little bit. But the exact content of the project isn't the significant thing that I want to share. What I want to demonstrate is what you might call object modeling, and I also want to demonstrate adding tests to an existing application that doesn't have any tests. With the object modeling part, basically we're going to take this big chunk of spaghetti code that I have, and we're going to tidy it up into distinct objects. And so rather than say anything more about that, I'll just get right into it and show you. So first of all, if I share my screen, I will show you the program. So what this is it's a genetic algorithm. A genetic algorithm mimics evolution in the real world. So each one of these dots is an organism. Each organism has a genome, which is just a fancy way of saying a set of rules that it operates by. Each organism can see, it can see up, down, left, right. These green dots are food, and so it can see if there's food up, down, left, right, and how far away that food is. And based on the rules in its genome, it will say, oh, okay, if I see food to the right, I'll go to the right. But the rules are random, so it might come out with bad rules, like if I see food to the right, go up, which obviously is not going to be successful. So these organisms live for a bit of time, and then they die, and a new generation is generated. The way they die is that they start off with a certain amount of health, and it costs health to move. And then when they eat food, they gain health. So if you move without ever eating, your health just depletes down to nothing and you die. But if you move toward the food and eat, then you gain health and you live longer and you can eat yet more food. And the idea is that these organisms evolve over time to um, to be better at eating the food, which does happen. You can see at the beginning they were just moving in random directions, and now they're moving toward the food and then eating the food. But they only adapt up to a point. Like they never get much smarter than this, which is kind of disappointing. So I need to figure out how genetic algorithms work a little bit better so I can make these critters get smarter better. But this is what I have right now. Anyway, the point is not to optimize this genetic algorithm. The point is to take what I have now and just make it more understandable so that when I gain some more knowledge and want to make changes to this program, it's easier to make the changes that I want to make. With that said, let's look at the code. So a lot of the code right now is contained in this main.py, which is kind of long, 73 lines. And if I scroll through, most of the 73 lines is just this main function. So that's maybe not great. That's a really big function. And what I've been doing so far is just going through, and I started at the top, and I'm trying to take things that are hard to understand and make them easy to understand. So here's what I'm going to do first. Jack, if you don't mind me calling on you, I'm going to ask you to do something for me. I'm going to ask you to start at the top of this main function and just within what you see on the screen here, see if you can identify anything that seems too confusing. And maybe if you don't mind, what you can do is just like start at the top and go down and describe what you think is happening. And maybe once we get to a point where it's too hard to instantly figure out what's going on, that's a sign that that's an area we could improve. How does that sound, Jack?
That works for me.
Okay.
Um, yeah, so what I'm seeing here is we start off with calculating a screen height based on the screen width with a random constant that of 0.618. Uh, initializing the game and then creating
All
a
right, sorry, let
cell
me pause you
screen.
there. I have already failed because that's not what this is. This is so we have a magic number here. And this is a great illustration of why magic numbers are not good. Um this isn't a random number. This is the golden ratio. Um because I wanted the height. Well, I wanted the height and width to be proportionate in that golden ratio. So I should really give this a constant called golden ratio or something like that. Anyway, that's probably kind of a minor thing. We can come back and fix that. But I wanted to point out that I did bad on that one. Anyway, continue.
Um, yeah, so interesting. I don't think I've realized that the golden ratio is that small, as it were. Um, yeah, so we're then setting up a cell screen object, whatever that is. We're setting up an ecosystem based on the cell screen. I'm going to guess that that is setting up all of the individual players. Set up a clock, set up a font. Uh, I'm guessing that's a font size of 36. And then we initialize a loop counter. And then we get an event. And I don't know what that first event get would be.
Me neither.
It would,
ChatGPT wrote most of this.
okay.
And kind of a general comment that I'll make is this chunk here is kind of just a bunch of miscellaneous crap. It's like a lot of incidental details, a lot of noise. So maybe we can do something about that at some point. Anyway, continue.
So then we jump into an infinite loop. Uh, sleep for a delay time, and then we loop over the organisms, allowing each of them to move. We're passing in the screen dimensions as a tuple, and then I'm going to guess where the food cells are in comparison to that.
Okay.
Which seems a little weird because then we offer them food.
Mm-hmm.
And then we kill unhealthy organisms, which I assume means if they've run out of health, then we kill them
Mm-hmm.
off. Um, and then if they're at a reproduction threshold, the healthiest organisms with another constant for how many are allowed to reproduce. I don't know why we would set organisms to an empty array on 37.
Mm-hmm.
Because if we don't have organisms, how are they reproducing? Um, but then it extends that array, so appending to it, I believe, the healthiest organisms and creates offsprings from them.
Yeah, so
There's
this
a
might be a good place to maybe we've identified enough confusing code that it's appropriate to start making improvements now.
yeah, I'd say this whole if block is pretty iffy.
Yeah. So this code came into existence in a certain way. So an interesting thing with crappy code is that like often nobody wrote the crappy code exactly. The code just came into being because it started off one way and then bit by bit certain parts were changed and then the end result is really hard to understand. No single person wrote that chunk, but since everybody kind of put their little spin on it, the end result is something confusing. And that's kind of what happened in this case. I wrote one line at one point in time and then I made a change, but I never stepped back and reconciled everything so it all made sense together. And so when you saw this, you're like, okay, I don't understand why we would set the organisms to nothing if the organisms are about to reproduce. So let's address that. Originally, it was the case that we would take the entire population of organisms, and when a reproduction event happened, we would just add the new offspring to the population. But then I changed it so that each generation starts fresh. But what I probably should have done is this. So I'm going to add some space to make it clear what I'm changing here. And I don't think this will be the only change we'll make in order to clarify this, but it seems like it's very silly to set an empty array and then extend it. We should just set the array because this is doing the exact same thing. I'm just doing it in a convoluted way here. So I believe I'm going to change that. And I have the beginnings, the very humble beginnings of a very small test suite. So I'm going to run that. Oh, and interesting, it fails. And I'm also going to test the program manually. But before I do that, I have a hunch that the test suite is failing, not because of the change I just made, but because of something else. And that's true. So I reverted my change just now, and I'm going to fix the test suite before I make this change, because I don't want to mix my bug fix with this refactoring. Organism.move takes 3 positional arguments. Oh, I see. I think I changed this, and then I never updated my test. Let's see what happens now. Yeah, okay. Okay, that was just a little distraction. Now let's do what we were really intending to do. Okay, so now I'm just setting the array like that. And let's manually test the program and see if it still works. And I'll let it cycle past this first generation into the second one. Okay, it appears that everything still works. So as I always do, I'm going to do a git diff before a commit. Nothing surprising there. I also always do a git status. So I'm going to commit that, and I'll just say refactoring. As I've said many times before, I think the commit message needs to be proportionate to how self-evident the change is. If the change is very self-evident, then I don't think the commit message matters that much. Oh, Jack had to leave us. All right. Okay. So let's look at this now. What do we think of this? We have the healthiest organisms, and then we're setting the organisms to the offspring. Let me, since we no longer have Jack available, Carl, let me switch to you if you don't mind. Would you like to look at this chunk, Carl, and help me figure out, because you have fresh eyes. I'm too familiar with this code. Maybe help me out with what still seems too confusing. What should we improve?
All right, let me have a look.
And if you could share your
Well,
thoughts out loud. Yeah.
I see the next line's the same kind of thing like previous, that ecosystem food cells is getting cleared and then extended. So you kind of
Yeah,
do the
interesting.
same refactoring.
Yeah, let's see exactly what clear does. So we can go to the ecosystem object. Oh, food cells is just an array. So maybe clear is a Python method that empties an array. In any case, I think we can just try this.
Then I also noticed previously you decided to do like a manual test, and I believe you did not rerun your test after the changes.
Oh, well, let's do that. Okay, passes currently. Okay, so we're at generation 1. As soon as it gets to generation 2, then I'll be satisfied. Okay, that seems to still work. All right, and I'll commit that. Okay. So what now? We're getting I'm just gonna kind of read this and see how much sense it seems to make. Healthiest organisms equals blah blah blah. Ecosystems dot organisms equals. It seems like maybe healthiest organisms could be a method on ecosystem, so that we can just kill line 36 and then replace this here with a call to ecosystem dot healthiest organisms. What do you think about that, Carl?
Well, the previous line looks pretty long,
Yeah.
but oh yeah, making a method. Yeah, that sounds good.
But then if we do that, we have to deal with organisms ordered by health. So we'll have to move that to ecosystem also, I suppose, but that's maybe no big deal. And I want to be careful about allowing ecosystem to become just a junk drawer for everything, but we'll deal with that in a moment, maybe. Okay, so I'm going to make these changes one piece at a time. First, I'm going to do this ecosystem dot organisms ordered by health. Okay, let's see if that still runs. I expect that it will. No, it doesn't. Oh, yep, I made a mistake here. I needed to put self in the function signature. And before I even run this again, I'm going to make it so it goes a little faster. I'll see. I'll set the reproduction threshold higher. Maybe that'll do it. Maybe I need to change something else. So I'll make the generation size 20 and the reproduction threshold 15. And I'll give them less life.
By the way, did you have a button to skip generations? I think earlier you said you're gonna skip a generation. Just curious.
Oh, I don't remember. That might have been a miscommunication. Yeah, I don't remember something about skipping generations.
And maybe you're just commenting what happened.
Okay. So I'll change their starting health and max health to 20. And I'll see what happens now. Does it go faster? Yeah, it goes faster now. Okay. So I should commit those changes separately from any refactoring. So let me do that. Oh no, sorry. I want to check out ecosystem. Okay, so this is only changes related to the configuration, but I think I inadvertently blew away some configuration changes, but the generations are still going as fast as I want, so that's okay. So I'll just say config changes. And now I'll go back and move this method, organisms ordered by health. Move it to ecosystem. Okay. And I'll change this to ecosystem dot. And then I'll run it and we'll see what happens. Okay, appears to still work. And even though my test suite is kind of a joke, I will run it again. Okay, still passes. Okay, looks like I accidentally added a blank line, so let me kill that. Okay, and I'll again just say refactoring. But there's something that's kind of silly now. We have ecosystem.organisms ordered by health, and to it we're passing ecosystem.organisms. Obviously, the ecosystem already knows about its own organisms. So we don't have to pass it. We can just do self.organisms. Okay, so let's run that. Okay, we're still good. And I will commit this. Okay, now I think we can move healthiest organisms to being a method inside of ecosystem. Okay, and of course, instead of ecosystem.organisms ordered by health, we'll do self. And we'll have to move this constant into ecosystem. Okay. And then we will change this to ecosystem.healthiest organisms. I'd be surprised if I did all that without making any mistakes. So we'll see. And in fact, I did make a mistake somewhere. I'm trying to see where the relevant part of the error message is. Oh, object of type method has no length. Oh, I know what I did. Somewhere I forgot some parentheses. There we go. Let's see if that works. Okay, it does appear to work. Okay. So let's review what we have now. If is population at reproduction threshold, ecosystem.organisms equals a generation from the healthiest organisms. We set the food cells to new food cells. and we increment the counter. How do you feel about that, Carl? Do you feel like that's good enough to move on and address something else, or do you think there are improvements we could still make in this area?
Well, both.
Yeah.
Yeah, I think probably one could make improvements, but I'd move on.
Yeah. Okay.
Like I just mean with the naming kind of thing, but it's understandable as it is.
Oh, I'm just
Generations
curious if
offspring.
you have any specific thoughts on the naming.
Well, it's kind of a new generation, but if you read the whole line, it's like generation dot offspring. So it also makes sense.
Oh, okay. Okay. Yeah. Yeah, I think you're right to move on. My kind of rule for myself when I'm refactoring is I refactor until I'm no longer sure that I'm making improvements. And if I were to do anything more, maybe I wouldn't be totally sure that it's an improvement. And so I'll leave it alone for now. And maybe if I come back on a different day, I'll have a clearer idea of what I want to do. Okay. So basically what we're doing is we're generating the new generation. And then down here, we clear the screen. Well, actually, let me turn it over to you, Carl. Do you want to take it from line 39 here and look at the code and see if you can tell what it's doing and if there's anything we should improve?
So I understand the next generation is starting, and yep, that's clear. It's, clearing the screen. Then the cells, I imagine, like pixels on a screen. That's how I understood it.
Mm-hmm.
And kind of redrawing the food cells for the new generation. And for organisms, I guess just rendering or drawing the new organisms. And draw
Yeah,
generation count. I guess I'm not sure. Is it like the same number of fritters each time?
it is.
All right.
Yeah, but the draw generation count, just so you have the context, it's this generation 2, generation 3, that stuff in the lower right corner.
What does clock tick does since you do those other changes and the games like the generations move faster?
I don't know what tick does.
So that
Um,
one's unclear.
yeah, let's do this because that was written by ChatGPT. I'm gonna say,
I think your clock tick is how fast it's running. So if you did double it, it would go twice as fast. I'm pretty
oh, I
sure.
see. Okay, well, I believe you, but I'm gonna type this in.
I'm not sure I believe myself, so yeah.
Okay.
All right, so we kind of cheated by making the game faster by making the organisms live half as long and those other changes.
Mm-hmm.
Okay, describing as a frame rate makes sense.
Okay, by calling clock.tick60, you're ensuring that your game runs at a consistent speed across various systems. Without this, the game loop might run very fast on powerful systems and very slow on less powerful systems. Interesting. So it's kind of a speed limit. Like,
Well, it wouldn't be true for the slow ones because if your machine couldn't actually run it at 60, it wouldn't get the 60. You know, it still could be less.
right,
Yeah. But to kind of stop the high end machines. Yeah.
exactly. Yeah, and we can see for my machine, there's too much, well, we can't really see it in the way it's configured now, but before when it would have a bunch of organisms in the beginning, it would run very slowly and then some of them would die and it would suddenly speed up. Okay, anyway, I guess that explains what that is, but maybe it would be nice to somehow make that clear in the code. No ideas
This
immediately
is
come to mind as to how, though.
so ChatGPT also said it's the frame rate,
Mm-hmm.
and that's a term like number two. Per frame is the desired frame rate in frames per second, and that's something we kind of understand from games. So I would
Yeah.
call it the frame rate.
Yeah, that's a good idea. And then even if we don't know what clock.tick does, the frame rate part will at least be a clue. Okay, so we'll manually test this and see if it still works. Looks like it does. Okay, add frame rate. Okay. And now maybe we can take a slightly different approach. This whole main file is rather large, and maybe we can come at it from another angle and take these methods one by one and move them to a more appropriate place. So this feels like it might be appropriate in ecosystem. And I do think we're going to want to break ecosystem into yet smaller objects, because I don't think the answer to what does ecosystem do? I don't think the answer to that question should be everything. That doesn't seem like a good idea. But for now, it's at least a better place than this main.py. Okay. And we're starting to get what you might call feature envy here. It's like ecosystem dot, ecosystem dot, ecosystem dot, ecosystem dot, ecosystem dot. It's like, why are we doing all this stuff on ecosystem here? Now that we have so many of these ecosystem things, maybe that should just be all happening inside of ecosystem. But we'll deal with that in a second. Right now, all I want to do is move this one function from here to there. So I'll run it again. Okay. And it fails because I didn't move reproduction threshold. Okay. Looks like it's good now. Okay. Okay, improvement. That's not even being called. This was kind of some debug output type stuff. So we can just kill this. Then I'll commit that. Remove unused function. Okay, draw generation count. Let's figure out what to do with this. This is a bit of a meta type thing. It's doesn't have anything to do with the organisms or the food or anything like that. It's just this like it's just so we can see which generation we're on. And I feel like maybe it should be its own object. I'm going to give that a try. So I'm going to create this generation count. Draw generation count. Well, I'll just move it for a second. I'm not sure if I'm going to like this, but we'll at least try it on for size and see how we like it. Seems like this stuff should go in the constructor. And then we do dot draw. Okay, so we'll move these things from here to the constructor. This is too much typing. So I'm gonna do this. I'm gonna go to ChatGPT and I'll say fix this. See if it's smart enough to figure out what I want. Part of the way I've been using ChatGPT is I'm trying to figure out what's the minimum amount I can give it when I prompt it and still have it do what I want. Because obviously the less I have to give it, the more efficient I can be in using it. And it looks like it did exactly what I want. So I'll grab that code and put it here. And we'll give that a go. Okay, generation count undefined, not surprising. We haven't imported it. So far, so good. Okay, looks like it still works. So I'm going to commit just that. That all looks good. Okay. Now, something that seems wrong is we're passing in font to generation count, but it's like, why do I have to care about that here? There's nothing else that uses this font. So it seems more appropriate to put that inside generation count. Okay. Font, where is that? Oh, okay, yeah. Okay. See if that works. No. Oh yeah, I didn't import Pygame. Okay. Well, Princeton, yep, okay, that works. And we have a magic number again, so we can fix that. We'd say font size equals 36. See if that works. Nope. I need to do self.font size. Okay, yep. Wonderful. Commit that.
So I feel like the generation count class is kind of like the game engine, which is one drawing or the count, but Pygame's also going to be drawing the cells.
Yeah. It feels a little bit weird to me. I don't know if this is your point, Carl, or if you're making a different point. but it feels weird to me that the cell screen draws the food cells in the organisms, and then the generation count draws itself. Was that your point or
Yeah.
something else, Carl?
Yeah, it feels like the code in generation count is doing, well, yeah, more. It's doing all. It feels like the game engine. That's that's how I'd say it.
Okay. What do you
Actually,
mean by that?
that the cell screen drawing the organisms is kind of doing the same thing as generation count, is just they drawing two separate things.
Mm-hmm. Yeah, let me see. Let's look at this cell screen and how it does the drawing, because I don't even remember how that works. It seems maybe even inappropriate for the cell screen to be the one doing the drawing. It almost seems like I should have a renderer or something like that.
Something like that.
Maybe let's give that a try. Okay. So we will want to have a single renderer. I'll put it near cell screen. Okay. And then down here, instead of cell screen.draw cell, I'll say renderer.draw cell. And obviously that's not going to work because we don't have any such thing. I'm going to import renderer. Okay. I don't know if I can do that. Okay, renderer object has no attribute, draw cell. Okay, so let's move this. See what happens.
So
Yep,
what
cell.
are we importing in the cell screen pie?
What are we importing in the cell screen pie?
Is
Oh,
it also importing Pygame?
it is.
So renderer is also going to, we kind of want to move that logic like to renderer, I feel.
Sorry, which logic?
The Pygame related things.
Yes. Okay, and cell width. It seems weird for cell screen and renderer to know about cell width. Maybe what should really be done is this. Maybe these things should go inside cell screen. Cell width becomes self.cell width. And then here we do cell screen dot cell width. And I think probably, obviously we need the cell screen in order to do that. So we can do this. Okay. And self.surface becomes cell screen.surface. Whoops. Okay, and then lastly, we need to pass cell screen into renderer when we initialize it. Let's see what happens now. Okay, cell screen is not, oh yeah, I need to do self.cell screen. Okay. Guess we still have another one. Okay. Cell screen object has no attribute draw cell. Yes, that's true. Where's that being called? Oh, from draw organism. Okay, so I guess we have to make both these changes at once. Okay, so far so good. All right, looks like it's working.
Yay.
All right. All right, so perhaps that's a step in a good direction. I'm going to commit what we just did. Okay, I feel compelled to give it a more descriptive commit message. Okay, so now we can come back to generation count and maybe be like renderer dot draw generation count, and then give it just that. That seems maybe better, right?
Yeah.
And I think this variable name is maybe not so great, but we'll come back and address that in a minute. Okay, so we can move this to here and move the font size to here. Maybe call it generation count font size. Whoops.
Kind of rename the method also.
Yeah. What was it? Draw generation count.
Yeah.
Okay. Then we can just delete this file entirely. Okay. And then I suppose we don't want to import it anymore since it no longer exists. Okay. Let's see if that works. Does not. Oh yeah, we need the count. What's that even called right here? Oh, interesting. Yeah, okay. I'm just going to call this count right here. Because in this context, it's pretty clear what count is referring to.
Yeah.
Cell screen object has no attribute. Oh, I call it surface. Okay. Okay, wonderful. Before we commit this, I'm just going to step back and look at what we have. Okay, renderer.draw cell, renderer.draw organism, renderer.draw generation count. Okay. That seems better. You guys think so?
I do.
Okay. Okay. Well, let's commit that. Okay, and this generation game loop counter, I'm not so happy with that. I think a better name would just be generation count.
Agreed.
Okay, great. Okay. Well, we're getting pretty close to time, so I'll probably call it a day soon. But I think we made a pretty decent improvement today.
How long was the file when we started again?
It was maybe like 73 lines, I think. So maybe some things for next time would be like getting this chunk. Right now there's still quite a bit to look at. It's hard to glance at this and immediately tell what's happening. So we could maybe compress some of these things, abstract away the details. Like maybe all this drawing could happen somewhere. I guess that all this is the drawing. Maybe that could be compressed. Oh, actually, even all this, maybe that could all be compressed down to a single line, like refresh screen or something like that. I don't know.
Yeah, I think that'd be a very common way to do it for those kind of games. You just have like a setup screen or refresh screen, I imagine. Yeah.
Yeah. So I think maybe that'll be a good one for next time. And maybe the reproduction can be compressed even into a single line. And this, I'm not sure what we'd call this. Maybe this is a sign that we need some clearer thinking in this area. But I think a lot of this could be compressed. And then a lot of this nuts and bolts configuration type stuff, we can probably improve that somehow too. I'm not sure yet exactly how. But in any case, I'm happy with the improvements we've made today. Okay. Well, I think I am going to call it a day. Anything we want to talk about before we go? Any questions or comments from either of you guys?
My one's like not really. It's kind of just what algorithm are you using? Are you using machine learning, or are you just using kind of like something you're playing with yourself for how to make the organism survive longer?
Yeah, good question. I would say yes to both. It is machine learning. So genetic algorithms are a form of machine learning. But it's a genetic algorithm that I kind of came up with myself based on some things I read a long time ago. But clearly I don't yet really know what I'm doing because my critters never get all that much smarter. Yeah, so I got to figure that part out. But yeah, it is machine learning because a genetic algorithm is one form of machine learning.
Cool.
All right. Well, thanks guys for joining me, and I'll see you next time.
Thank you.
Thanks.
Bye, guys.
Bye.